The overall equation for the electrolysis of aluminium oxide is this. Calculate the mass of oxygen produced when 2,000 kilograms of aluminium oxide is completely electrolyzed. And I've got my relative formula masses. So my instruction is to calculate the mass. So I'm going to need my mass Mr. Mole equation to jot that in to remember it. And let's check kilograms. So they're trying to trick me here because that's in kilograms, and moles, if you remember, that's got to be in grams. So if 1 kilogram is 1,000 grams, I'm going to have to get a bigger number. So I need to times by 1,000. So it's going to be 2,000 times by 1,000. Right. So I've done my working, my thinking there. Now I can start with my table. So as usual, I've got 2 columns, well, 1 for my notes and then 2 for my different substances. So I've got my mass, Mr. Mole, rat, and rat being short for ratio. Right, what do we want? Calculate the mass of oxygen. So I've got oxygen, and that's the thing I'm trying to find. Produced when 2,000 kilograms of aluminium oxide. So I've got aluminium oxide, and I've got, I know, 2 million grams. Right, let's put in our formulae. So oxygen, if I look up here, that's going to be oxygen. So I'm ignoring big numbers, only little numbers, is O2. And aluminium oxide, well, that's aluminium by itself, so that must be aluminium oxide. That's Al2O3. Right, so MR then, I've got O2, so I've got 2 lots of 16, which is 32. And then aluminium oxide, I've got 2 lots of aluminium, so that's 27 times 2, and I've got 3 lots of oxygen, so that's 16 times 3. Add that up, we end up with 102. Right, so I've done my MRs, now I'm going to come to my mole of the one I know about. So to work out moles, I need to do mass divided by MR, so it's going to be 2 million divided by 102. Now if I put that in my calculator, I'm going to end up with a big long number. So I need to keep this in my calculator as it is to avoid rounding errors, but so that I'm making sure I pick up marks on here, I'm going to make a note of the number so that if I mess it up later, the examiner can still see what I'm doing and give me some marks hopefully. So it's 19608 on there. Right, leaving it in my calculator because I don't want to make rounding errors, so I'll put that to one side for now. So my ratio, now I've got to look at the question. So I've got oxygen, I've got 3 lots of oxygen for every 2 lots of aluminium oxide. So my ratio is 3 moles of oxygen to 2 of aluminium oxide. I don't have 2, I've got this many. So I need to divide by 2 to work out what 1 part is, and then times by 3. So I'm going to do divided by 2 equals, times by 3 equals. And again, I'm going to leave that in my calculator so that I minimise my rounding errors, but make a little note so that I'm picking up the working marks. 29412. Okay, so got that there. So I've worked out my moles. Now my last step is to work out the mass. So mass is MR times by mole. So I need to do that number times by 32. So it's 29412 times by 32 equals 94117.6. I'm going to put 0.47 in there. Now let's do a check. That's in grams because mass is in grams. What do they want my answer in? Kilograms. So I need to go back again to convert it back to kilograms. So I need to divide by 1,000. So divide by 1,000 gives me my answer. Now there isn't any instruction about number of decimal places or significant figures, anything like that. So it doesn't really matter what you put in. There's only one significant figure in the question. I'd suggest going more than that. So I'm going to go for 94117.6. 1.2. That's your answer.